Hi, this is the Science Chef. In this video, we'll be looking at the second part of our tutorial on the qualitative analysis for the 2024 WAEC Chemistry Practical. The qualitative analysis is about a mixture of two salts, sodium trioxocarbonate 4 and lead 2 trioxonitrate 5. These are the salts. You can see sodium trioxocarbonate 4 and lead 2 trioxonitrate 5. Good. So now this is a mixture of the two salts. You can see the white mixture. Both of them are white salt. Okay. Then we have here iron 2 tetraoxosulfate 6, which we are going to use to prepare freshly prepared iron 2 tetraoxosulfate 6 solution. That is freshly prepared FeSO4 solution. And then we have the reagents to test for the cations and the anion. We have sodium hydroxide here. We have HNO3, 2 molar HNO3. We have 2 molar ammonia solution, bench reagent, and we have 2 molar HCl here. Then we have our wash bottle. Then we also have a concentrated H2SO4. Concentrated H2SO4 for the brown ring test. Now, given there is a mixture of two salts, then it's likely that from the last video, we showed you that the reaction is a double decomposition precipitation reaction in which the lead 2 trioxonitrate 5 and the sodium trioxocarbonate 4 will combine to form insoluble lead 2 trioxocarbonate 4. So we are going to take a sample of that. We're going to take a spatula full of a sample and add it to the boiling tube, and then we add distilled water to dissolve it. Of course, it will not dissolve. You don't expect to get a clear solution because of the precipitation, right? So if I would advise, since we are expecting a precipitate, I would advise that we add more salt so that we have enough residue to work with. So the next thing is to fold a filter paper. So let's keep it aside so you can see what I'm doing or see what you're doing. The next thing is to fold a filter paper. You don't have to fold it. First of all, you fold it into a half, and then into a quadrant, and then open it up as a cone. Open it up as a cone, then place it on your filter funnel, right? So I'm going to pour this mixture. I'm going to pour this mixture into the filter paper and allow it to filter out. Allow it to filter out. You can see it's dropping. You can take it closer. You can see the filtration is taking place. Right? Good. This will take some time. So while the filtration is going on, you can be working on your question 3. I'm working on your question 3. Please, when you're pouring into the filter paper, ensure that it does not spill into the filter funnel so it does not interfere with the filtrate. You can see the clear filtrate that we are getting, and that is sodium triethylnitrate 5 that we spoke about in the first part of this tutorial. This is a slow process, so it will take a bit of time. We will have to fast forward this video, right? But in your actual exams, while waiting for the filtration to take place, you can always continue working on your question 3, or you complete the calculations on your question 1. So while we wait for the completion of this filtration, we'd like to acknowledge the Chrislam Pre-Degree College for allowing us use their facility to shoot this video. Chrislam Pre-Degree College is the sixth form college situated in Lekki Phase 1, Admiralty Way, directly opposite Ebano, and they offer international courses, short courses and programs like the CIE, Advanced Subsidiary and Advanced Level programs, and they have well-qualified lecturers that will tutor you or your ward to obtain the best results. Last year, they produced the best student in the world, the top in the world in law and psychology. So we are very grateful for this privilege they've given to us to make use of their facility. Apart from the A-level program, they also run a Canadian pathway program called the Ontario Secondary School Diploma. That's the OSSD. That grants you admission into Canadian universities, right? And also, you also have another program called the Foundation, International Foundation Program, IFP, and other numerous programs. They train students on SAT, TOEFL, IELTS, and the likes. So, and even IGCSE, can you imagine? Even IGCSE. They are jack of all trades and master of all, right? So why don't you give them a try? They have well-equipped laboratories and classrooms, right? Everything is comfortable. They have dormitories with ACs, football pitch, everything, right? A gym where students can go for their exercise or fitness training on weekends, and a whole lot. I bet you, if you choose the Chrislam Pre-Degree College, you will not regret it. Okay, our filtration is almost done. What do you think about chemistry as a whole and chemistry practicals in particular? It's very interesting, right? Let's have your comment in the comment section. All right, I think our filtration is complete. So let's bring it out. You cannot get 100% separation because of time. You can see the filtrate there. You can see the filtrate there. And you can see our residue. Can you see it? Yes, you can see the residue. Good. So I'm going to remove it and open it up to get dried a bit. Yeah. So let it dry. Let it dry up. At this point, you may need to switch on your fan. Can help it dry. So now, while the residue is drying, let's carry out the analysis on our filtrate. Our filtrate again is sodium triethylnitrate 5, NaNO3. So the ion that we'll be testing for there is the triethylnitrate 5 ion, and the test we'll be carrying out will be the brown ring test. So we're going to take a little portion of that. Before we do that, we need to prepare iron 2 tetrasulfate 6 salt. It must be freshly prepared to prevent it from being oxidized to iron 3. You can be asked that question. That's a common question in your question 3. Iron 2 is easily oxidized to iron 3. So that's why whenever you want to make use of iron 2 salt and iron 2 salt in an experiment, it must always be freshly prepared. So you can see I'm preparing my iron 2 tetrasulfate 6 live and direct. right? To prevent oxidation to iron 3. So having prepared a iron 2 tetrasulfate 6 solution, we're now going to carry out the brown ring test on the filtrate. That's to test for the 1295 iron, right? Using the concentrated H2SO4 and the freshly prepared FeSO4. So this is the filtrate. Remember, these are filtrate. So you have a portion of the filtrate, and then we add a portion of the freshly prepared iron 2 sulfate, iron 2 tetrasulfate 6, right? And then we'll take, using a drop pipette, we will add the concentrated H2SO4. You have to be very, very careful here. Slowly down the side of the test tube. Look at the test tube. Look at the test tube. Look at the test tube. Can you see the brown ring that's beginning to form at the bottom? Can you see it? You add it gently. You add it gently. Can you see it there? Can you see? Can you see the brown ring there? That confirms the presence of the tri-oxonitride ion. Yeah. Can you see the brown ring? Now raise it gently, 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 gently. Wow, this is beautiful. This is beautiful. The brown ring forms at the junction of the aqueous and the acid layer. Can you see it? Wonderful. All right. So that confirms the presence of the tri-oxonitride ion. Okay. So we are done with that test. So let's drop that and now move on to our residue. So we are done with our concentrated acid. So our residue now, for our residue, we are going to dissolve our residue, a part of our residue, in we're going to add dilute HNO3 to our residue in a boiling tube. But we can't use dilute HCl nor dilute H2SO4 because they will form what? Precipitate with the lead-2 ion. They will form the lead-2 chloride and lead-2 tetrasulfate 6 precipitates. But it is only the dilute HNO3 that will give us a colorless solution. Now, but given that this is a triazocarbonate 4, that's like 2 triazocarbonate 4, we expect effervescence or bubbles to occur, effervescence of a colorless and odorless gas. Wow. Can you see that? Can you see the effervescence? Can you hear the sound? Isn't that beautiful? Isn't chemistry beautiful? Looks like magic. Yeah, can you see the fizzing from the bottom of the boiling tube? Just like your Andrew liver salt, right? Good. Yeah. Can you see everything has it dissolved completely? Almost. Let's add more to ensure everything dissolves. Okay. Yes, everything has dissolved. Good. So from here now we're going to divide this guy this solution into 3 portions. The first portion, second portion, and the third portion. All right. So we are done with our freshly prepared FeSO4. We don't need it again. So let's do away with it. All right. So to the first portion, we are going to add sodium hydroxide in drops. To the first portion, we add sodium hydroxide in drops, and we expect to get a white precipitate in drops. Can you see? White precipitate in drops. And we now add in excess. We expect this precipitate to dissolve. Wow, it dissolves to give us a colorless solution. So that means that the ion present there is what? Is an amphoteric what? Ion, which is like 2 ion, right? So in your inference, you can either assume or yes that ion 2, zinc, aluminum, or lead ions are what present, but since it's not gelatinous precipitate, it is okay to assume only lead. But let's carry out further analysis to confirm that it's not zinc. We never can tell. So we are going to add aqueous ammonia. If you add aqueous ammonia to this, you expect to have a precipitate that will not dissolve in excess of aqueous ammonia. So that is a white precipitate, right? So will it dissolve in excess? I don't know. Let's see. Can you see? Precipitate is insoluble in what? Excess. So definitely it's not zinc. And given the type of precipitate that forms here, looks like a chalky precipitate, which like it's not. But let's try to carry the confirmatory test for lead 2 by adding what? HCl. So we're going to add by adding HCl, we'll get a white precipitate of like 2 chloride. If we get a white precipitate, then it means that the cation present is what? Lead 2, because the other cation whose precipitate dissolves in excess sodium hydroxide but does not dissolve in excess ammonia is aluminum. And when you add dilute HCl to an aluminum salt, there will be no visible what? Reaction, because aluminum chloride is what? Soluble, right? So this is HCl is always used to distinguish between aluminum ion and lead 2 ion. So if we add this HCl to this solution and we get a white precipitate, that means that the cation present there is lead 2 ion. Though you will be asked to warm the precipitate, which is expected to dissolve on heating and allowed to stand, and by so doing, the precipitate will what? Reappear. Unfortunately, I'm not going to do that because it's already obvious that lead 2 ion is what? Present. But you can try it out. You warm it, it will dissolve when heated, and then allow it to stand or cool. The white precipitate will what? Reappear. All right? So let's do that. I'm adding dilute HCl now. Can you see the white precipitate? So what else do you want? Do I still need to heat it so that it will dissolve and then reappear on cooling? Of course it will dissolve and reappear on cooling, but I can't do that right now. I'm sorry about that. I can't do that right now. It's already obvious that what we have here is what? leg 2 ions, right? So at this point, after warming and allowing to cool, you can state that precipitate dissolves on warming and reappears on cooling. Then Pb2 plus confirmed. Precipitate is lead 2 chloride. All right, so that brings us to the end of our tutorial on the second part of the qualitative analysis for the 2024 WAEC Chemistry Practical. If you have any questions on these practicals, right, on what you have just done, please don't hesitate to drop it in the comment section. We will attend to it. And then also, if you obtain any value from this video, please hit the like button, subscribe, and also share to your friends and to your contacts, right? So that they too can learn. Together, we can help each and every one of us to do well in the exams. So until we come your way next time, always stay safe. Thank you, and God bless.